Hello everyone, my name is Ayush Singh, pursuing BCSC from Sri Venkateswara College of Engineering, and today in this video we will be talking about quicksort. So let's first talk about what is quicksort. It is a divide and conquer algorithm for sorting data efficiently, developed by Tony Hoare in 1960. It works by selecting a pivot element and partitioning the array. Elements less than pivot go to the left, whereas the elements greater will go to the right. Recursively applies the same logic to subarrays. Average time complexity of quicksort is big O and log n. Worst case time complexity is big O n square, typically avoided with good pivot choice. In place algorithm requires little additional memory, widely used due to its speed and efficiency in practice. If we talk about applications of quicksort, database management, operating system, numerical computations, and embedded systems. In database management, it sorts by keys for quick data retrieval and indexing. In operating systems, it schedules tasks effectively by sorting data based on priority. Numerical computations sorts data arrays to support statistical analysis and simulations. Embedded systems in embedded systems optimized for limited memory environments due to in-place sorting. If we talk about algorithm of quicksort, it is a recursive sorting algorithm that works by selecting a pivot element and dividing the array in two parts, one with elements smaller than the pivot and the other with elements greater than or equal to the pivot. The function takes three arguments: the array, a low index, and a high index, which represents the current subarray to be sorted. If the subarray has more than one element, that is low is less than high, it calls the partition function to place the pivot in its corrected sorted position. The partition function chooses the first element of the subarray as the pivot. It then initializes I to the index immediately after low and begins scanning the rest of the subarray using a loop variable j. For example, for each element, if array of j is less than the pivot, it swaps array of I and array of j and increments I. This way, all elements less than the pivot are moved to the left side. After the loop ends, it swaps the pivot element with the element at array of I minus 1 effectively, placing the pivot in its correct position in the sorted array. The partition function then returns the index I minus 1, which becomes the pivot index. Finally, quicksort is recursively called on the two subarrays to the left and right of the pivot, continuing the process until the entire array is sorted. Let's trace an example of quicksort. Here we will have 5 elements 0 to 3. We will be taking the fourth element or the 3 indexed element as pivot. Here it is 40, and initialize I is equal to minus 1 and j is equal to 0. Since a j is at 0th index and we will compare the 0th and pivot, so there will be no change as 10 is less than 40 here. So I will be incremented to 0 and j will be incremented to 1. On the next step, will see area of j is at 1. Pivot is greater than the 40, like the 80 is greater than 40 here. So no swap will be done and j will be incremented by 1. Here the j is incremented to the index 1, 2, sorry. The index of j is incremented to 2, and here also 30 is less than 40. So we will be swapping the previous element 80 and 30, and I will be incremented by 1 and j will be also incremented by 1. On the next step, we will see that pivot, the J is on the second index, and 90 is greater than 40, so no swap will be done and J will be incremented by 1. On the last, we can see that no of the, like, J cannot increment any more further. So what we will do, we will swap the pivot and the I plus 1, which will be 2 here. So 80, the position of 80 and 40 will be swapped in between. If we talk about summary and conclusion, as we talk about advantages, uh, Quicksort gives us fast average performance and efficient memory use. If we talk about disadvantages, the worst case can degrade, mitigated by pivot strategies. Alternatives: merge sort and heap sort offer stable or guaranteed times. Best use when average case performance dominates typical scenarios. Thank you. That was all for this video.